Ooh. Algebra students, Mr. Lawrence here, and we are going to be learning how to graph absolute value functions. But before we do, we have to make sure we know the definition of absolute value. And I've talked about this before, and you've used it. Remember, the definition of absolute value is the distance from 0 on a number line. That's a definition you must use. If you don't use that definition, you'll have a difficult time. For example, I know most of you can tell me, well, absolute value of 5 is 5. And you can tell me the absolute value of negative 5 is 5. But then when I ask for the absolute value of x equals 7, all you say is 7. And that's incorrect. You see, on a number line, if I have 0, it's true that if I go 7 spaces out, I do end up at 7 if I go in the positive direction. But what if I go 7 spaces in the negative direction? I end up at another number, negative 7. And so you see, it has two possible answers. So make sure you use the definition, distance from 0 on a number line. All right, now normally we don't use a table, and I'm only going to use it this once. Are you hearing this? Do you hear this, Kevin? Holly? Aiden? We're not going to use a table to graph these. There's no need to use a table. A table is a waste of time. This table I'm going to use because it'll help you understand how this works, but after that we won't be using it. All right, so I've picked some very important x's here, and I'm going to take the absolute value of each one of those because that's what y is. Y is the absolute value of x. So the absolute value of negative 3, how far is negative 3 from 0? It's 3 spaces. How far is negative 2 from 0? It's 2. Negative 1 is 1. 0 is 0 spaces from itself. Positive 1 is 1 space away. Positive 2 is 2 spaces away, and positive 3 is 3 spaces away. When I graph it, I'm going to get a picture that looks just like, where is it at? That. See the y equals absolute value of x? Notice it's here, starts at the origin. Well, it has a vertex at the origin. Yeah, we call this the vertex down here. The vertex. Okay, and this vertex is at the origin. And then 1, 1 is right there, 2, 2, 3, 3, and negative 1, 1, negative 2, 1, or negative 2, 2, negative 3, 3, etc. And it goes on forever. Okay, now, that's what the table did for me. But I'm wondering what would happen if I had a more complex function. Like say, let's go in here and put a plus 2 in there. Well, look at that. My vertex shifted 2 to the left. When I did plus 2, it shifted 2 to the left. What would happen if I shifted it plus 5? Well, it went 5 to the left. Maybe you know what would be really cool is if I left the original up here. Oops. Let's see, absolute value of x. And then let's try this other one. We got y equals, and we're doing absolute value of x, and we tried plus 5, didn't we? And there you can see it actually shifted. The gold one, the original one, is not part of the graph. But the graph is identical, except the whole thing moved left 5. Positive 5 moved it left 5. I wonder what a negative do, like if I did minus 3. Oh, look at that, it shifted it right. It shifted right. Well, that's pretty cool. All right, what do you think would happen if I added or subtracted on the outside of it? Let's try a plus 2. Ooh, it moved up. How about a minus 2? What would a minus 2 do? Hold on, I lost my whole thing there. Minus 2. Oh, it shifted it down. Huh. You know, I'm just thinking crazy here. What would happen if we did something inside, like plus 3, and then we did something outside, like, I don't know, minus 4? Well, look at that. The vertex shifted from the origin. The whole left, 1, 2, 3, and then down 1, 2, 3, 4. So maybe we can use that to find the vertex. Maybe, just maybe, we can find the vertex. Let's use some letters for our vertex here. And let's go y equals Abs value of x plus h. Sorry, it's curved and really shouldn't. X plus h plus k. Maybe the vertex should be located at the negative of h, because it did the opposite thing, and then k. Yeah, well, let's try it here. Oops. Let's try here. If I'm right, the vertex of this equation should be at 3, because I take the opposite, and then I take the number that's added here. Well, there's nothing added there, so that would be like plus 0, wouldn't it? Wouldn't there be a plus 0 there? So the vertex should be at 3, 0 if I'm right. Let's go to the graph and see if we get that. So let's see here. Let me put a 2 there, and then let me do that. Yeah, the vertex is at negative 3, 0. Now wait a minute, the black V looks a little bit different than the original V, the brown or gold or whatever color that is. Look at that. This one, to go to the next point, we rise 1, run 1, rise 1, run 1, rise 1, run 1. Here we rise 1, go back 1, rise 1, go back 1, rise 1, back 1. Here we're rising 1, 2, and then running 1, rising 2, running 1, rising 2, running 1. Oh, I wonder if this number here, the number in front, is like the slope. Only to get the V shape, we need 2 slopes. We actually need 2 slopes. We need the rise over the run like we normally would do. And then we need the rise over the negative of the run. So we get 2 slopes just like that. Yeah, that's pretty cool. Hey, what was the slope here? Well, it would have been 1. And so they would have done a slope of 1, 1, and a slope of 1, negative 1. Right? Okay. Let's try this one. Let's see if we can find the vertex. Looks like this one, the vertex should be, there's nothing added in here, so it's like plus 0. And then I just take that number out there. And then my slopes are going to be 1/4 and 1 over negative 4. Oh, I want to see if I can graph this on my own. Let's get a graphing sheet of graph paper out here. Let's make it a little bit bigger. Control L. And I should label everything with the origin and the x-axis and the y-axis. Now my vertex is at 0, negative 2, so my vertex is right there. And then I'm going to rise 1 and run 1, 2, 3, 4. Rise 1, run 4 like that. And so my graph is going to look like that. And then I got to do the other half with the other slope. So I'm going to rise 1, go negative 4, rise 1, go negative 4. And this looks like it's going to be a real wide V. The other ones didn't look so wide, did they? So it's going to be something like that. Looks like it's off a little bit. Oops. Sorry, that doesn't belong there. And this one here is like that, right? Let's go and see. What is it? 1/4 absolute value of x minus 2. All right, let's bring it up here. So I need to get a 1/4 there. I wonder how it wants me to do a 1/4. Well, I can go 0.25. Ooh, look at how wide that got. And then the equation, it's x on the inside and minus 2 on the outside. Okay. So then I need an x right there, and then a minus 2. And look at that. It's crossing at negative 8, 0 at the x-intercept, x-axis, 8, 0, and that's what I got mine doing. Yeah. Well, this might be pretty easy to do. Let's see. Oops. Sorry. Okay. Okay, let's see if we got any more down here. Yeah, we got another one. Let's see what happens with this one. All right. If all my hunches are correct, my vertex will be, change the sign there, so I get a 4. Take that -2. My slopes should be 2 over 1, and then 2 over -1. Excuse me. So, I'm going to bring out my graph. And I'm going to go Control L, label, origin, x-axis, and the y-axis. And then I'm going to go 4, -2. So 1, 2, 3, 4, 1, 2. And then we're going to rise 2, run 1, and rise 2, run 1 the other way. And that will get me a V like that. Right? So let's see. Let's go back to that Desmos size and check my work. 2 times the absolute value of x minus 4 minus 2. So, okay. Let's see here. Let's return. Go 2 times the absolute value of x minus 4 minus 2. And that red one looks an awful lot alike. Look at the vertex it's at. 4, 1, 2, 4, -2, which is what I said it was at, didn't I? Yep, 4, -2. So this is pretty easy. So let's sum this up here. What did we do? Well, we're given an equation like this. Y equals, I don't know, 3 times the absolute value of x minus 4. Oh, hold on a second. Let me start this over. Sorry about that, just having a little mental blank. All right, let's go 3 times the absolute value of x plus 2 minus 5. And the first thing we did was find the vertex. Okay, find the vertex. And we get that by changing the sign here, so taking the -2, and then -5. And then we find the slopes, right? And the first slope would be 3 over 1, and the second slope would be 3 over -1. And then all we did was graph. And we end up getting a V-shaped graph. I don't know if you noticed this, but if our slope was bigger than 1, like 3 whole number, the V got skinny. Excuse me. And if the slope was like a 1/4, the V got really wide, which makes perfect sense because you're not rising as much as you're running. And so you're going up a little bit, but you're going across a lot more. All right, that's how you graph absolute value functions. That's it for the video. Mr. Laurence signing off. Have a good night, everybody.